All right, good afternoon, everyone. I will begin today's webinar with injection molding simulation and structural analysis convergence. I am the customer success engineer here at the Farmington Hills, Michigan location in the U.S. So the content of today's webinar, we will go through how fiber influences structural parts. We will talk about how we can use Moldex 3D FEA interface to help us aid in structural analysis, comparing isotropic and anisotropic properties and how your structural simulation will reflect on these anisotropic and isotropic mechanical properties due to your fiber orientations. I'll show you some case studies, and then we'll wrap it up with any questions, comments, and concerns. So the influences of fiber. So for unidirectional fiber, that's one direction fibers, your modulus becomes maximum when the loading is parallel to your fiber direction, as you can see on the graph. As your fibers become more perpendicular to the loading, the modulus goes down due to the orientation. For biaxial fibers, the woven fibers, the direction doesn't really play too much of a role in different moduluses for your parts. It's relatively the same. In fiber orientation, typically people look at the skin core layers, or there's also the shell layers also, but the skin core effect. So basically, we look at right at the material or the fibers are at the skin or at the surface of the part. And then we look at it the shell, which is right below the skin, and then we have